Hello and welcome. This is a tutorial I want to create for C++ programming. My goal for this video is primarily for a course I'm teaching. I am putting this on YouTube, so I hope that it's going to be useful to a wide range of audiences. So for my students, there's going to be a lot of redundancy because I want it to be generally accessible. But I think that hearing a topic second or third time is good. It helps it to sink into your brain and helps you to really understand it better. So what I'm going to do is I'm going to make a couple classes. I'm going to talk about a few key concepts in those classes. Then I'm going to be really careful to emphasize the role of some features that I wasn't able to emphasize in my course. When we were teaching in the class, we learned about classes before we learned about constants because I wanted to get to classes quickly. So I'm really going to talk about how constants play a role in class creation. Also, we're going to look at a reference. We're going to learn a lot more about references later, but it's kind of good to know what references are. Alright, so when we get started, I'm using CLion. And in CLion, hold on, let me have some old stuff from testing. So in CLion, what we're going to do, okay, here we go. So we're in CLion, and what we're going to do is we're going to add a new class. We're going to call this class point. And all CLion is doing is it's creating a point.h and a point.cpp file, and it's adding those files to a project. When we work in an IDE, part of what it does is it manages details beyond only the files. If the only thing our IDE does is manage files, we don't call it a development environment, it's just a text editor. CLion uses this cmakeLists.txt to keep track of which files are in our program. Okay, so in our point class, we have to define what our class is going to have. We're going to have a private variable. We're going to have a double x and y. And that's it. Our point is just a two-dimensional point. Now we need to create some constructors. Our first constructor is going to be just the empty constructor. And I kind of like this list initialization. And what this does is it allows us to say, hey, before we even jump into the constructor, we're going to initialize our variable x to be 0 and our variable y to be 0. And we can do the same thing too. We can do double x, double y. And with the list initializer, it kind of gives us this sort of cool ability to say, hey, yeah, we have this input double x and this input double y, and it knows that when we're using x like a function after this colon, it knows that the x that's acting like a function is the variable x that's in the object, and then the x that's being passed as a parameter is the x that's coming in through the constructor. So it's just kind of a nice way to keep track of. We're also going to use what's called a copy constructor. And for the copy constructor, we have to use a constant. Constant. And we're going to use a constant point, and then we do the ampersand, and we're going to give it some sort of point for input. And the reason we're passing a constant point is because when we're copying the point. So the point we're giving it is not changing. We're simply going to use the values from the point we're giving the constructor to make a new point. Okay, so we have this point for input, and the point that's being input is not going to change, so it's a constant. And we have to do that for a copy constructor. The compiler won't allow us to do otherwise. And part of the standard for a copy constructor is we don't actually give it the point, we give it a reference to the point or a handle to the point. And that's why we're using the ampersand. We're saying, hey, I'm not going to give you the point, but if you see this point over there, use that point. And that's what this ampersand means, is it says, hey, look at this point named point and use what that point has to build yourself. So it's sort of a way of giving a variable to the constructor without actually having to move it or anything like that. We just say, hey constructor, look at this point over there and use it to build yourself. Okay, before we do that constructor, we are going to have to create some getters and setters. So we're going to create double get x. Now we're going to declare this as a constant. And the reason we do that is we don't want someone to say something like get x equals 5. Because technically when we declare this function, we're going to return our private variable x. But x is a private variable. We don't want to give any opportunity for the outside world to change it. And declaring it as a constant really makes that possible. It makes us say, hey, this value being returned can't be changed. All right, okay, so double get y constant. I'm going to delete that comment because it wouldn't make sense out of context. All right, void set x, and that's going to have double for input. Void set y, and that's going to have double for input. Void void print to screen. When I'm creating new functions, especially when I'm testing and playing, I always like to have a print to screen method. I'm also going to create a quick method that is going to add 2 points together and return a point. Once again, this summation method isn't going to work if we don't have our constants in the right place for the copy constructors, because yeah, it gets kind of finicky. So we have to be really prudent about being strict to our code. I think this is everything we really need for the time being. All right, so we'll jump in and we'll create the methods here. CLion is really cool. I do love it. Partially because one thing you can do is if you just right click, you can go down to generate. All of the IDEs being developed by JetBrains have this generate in the code. Now what you can generate varies from program to program. But I love the fact that you can implement the functions. And what that's going to do in C++ is when you're in a CPP file like we are right now, the implement functions is going to go look at the header, and it's going to say, hey, which functions are there? So let's click on implement functions. All right, so we can choose the top level or the point. So I'm just going to click on point functions. I don't know why it doesn't give us all of them, but we're going to select all of these. Click OK. So we still need to construct this, this constructor. So what I'm going to do is I'm just going to say, well, this x, so the x of our variable is going to equal to point.getX. This y is equal to point.getY. And you know what? I think I need an equal sign here because I was just stupid for a second. That's basically how we're doing for our construction. We just we assign x and y. That's the only data. This is a super simple object. For getting x, we're just going to return x. We can also use the this keyword. This refers to this current object, and then this x is just going to say, hey, you know the x that's part of me, return that one. All right, and then get y is going to return the y that's part of us, and that's part of this object. Now, because I used the generate command, you're also going to notice we have this point followed by the 2 colons. And what those 2 colons do is I often refer to them as like a class operator or a namespace operator. And what it really does is it specifies which class or namespace you're a part of. So when we say point : we're saying, hey, in that namespace of point or in the class of point, in the area of the program all grouped together as a point thing, we're referring to that one. And when we're generating our class, the class is defined in point.h. And when we're generating the class ends at the end of the semicolon. And when we come to the CPP file, we've loaded the point.h first, and then we're doing all of these operations. And the thing is, we're outside the class, but we're trying to do something inside the class. And by doing point : we're kind of saying, hey, inside of that point class, inside of maybe the scope of the point, do this. I think I've also heard this referred to as a scope operator for the colon colon. I don't spend a lot of time memorizing the names of different symbols. I just try to program and get things done. All right, so before every function, you can see we have this the class followed by the scope or class operator. Now, when we generate the add function, we can see this add is defined outside of the class. It's just kind of a helper function. And because it's outside of the class, we're not going to need a scope operator for the sum, but we do need the scope operator for everything that's inside the class. Part of the reason I added point was to show this difference. All right, so for set x, I'm just going to say this x equals, I'm going to call it x. Oops. I'll probably put a semicolon there. We're going to say this y equals y. All right, for print to screen. All right, for printing to the screen, we are going to need another function or another function from some headers we don't have. So we have to include. I'm going to use IOStream. All right, and then for printing to the screen, I'm going to say so cout is in the standard library, so I'm going to use std followed by the scope operator because we're looking inside the scope or the namespace of std, which is our standard operators. All right, so first I'm going to print the opening parentheses, then I'm going to print x, or this x. We really don't need this when there's no conflicts. Sorry as I type here and not talk. Standard operator and line. All right, and this is basically how we're going to print our point to the screen. This is going to be the x and the y. Let's quickly define the sum. So if we come down to generate, we're going to implement functions. It'll automatically find the sum here. All right, so we need to create a point and return it. So I'm going to create a point for the value, and I'm going to just say that the value dot set x. We're basically going to take the a dot get x plus the b dot get x. So we're essentially going to get x from a and add it to the x from b. So we get x from a, we get x from b, then we add them together with a plus sign. Then we're going to do the same thing for y. I'm just copying and pasting here, x to y, x to y. Turn that x into a y. There we go. So for the value, we're going to set x by adding the get x from a and the get x from b. We're going to set the y by adding the get y from a and the get y from b. And then when we're finished, we're just going to return our value. All right, so pretty easy sum. And then because the point is outside of the class, we don't need to reference it into the class. So we don't need to have the point colon colon before it. I remember when I learned programming, it wasn't clear to me why we used these namespace operators there. I think my professor was more concerned with the name of the operator than why we actually need them. All right, so we can jump into main, and we can test this out. We're going to include point.h. Because we created the point.h and it's in our local directory here, we need to put the double quotes around it, not the less than and greater than symbols. Point A, we'll make a point, we'll call it, how about Q5. We'll make another point, B, we'll call it, how about 3 and minus 10. Then we'll make a point, C. C, I'm just going to leave it as an empty one, because what I want to do is, I think I want to do, actually, you know what, I can do C equals sum AB. So here I'm going to use my sum function to define the C. I'm just going to do a dot print to screen, b dot print to screen, c dot print to screen. Okay, so I'm able to make these functions and print them to the screen. All right, I should be able to build this in CLine, I think. Yep, here we go. I've run this before, so I don't have to retell it which file I'm using for the executable. Alright, so we can see that everything here works. 2 plus 3 is 5. 5 plus negative 10 is negative 5. Alright, so we have a working point. So I'm going to maybe pause the video here, and I'm going to real quickly make a complex class. It's going to be very similar to the point, and I'll just go over some of the differences right after I make it. So I'll be back in a moment. You won't notice any time. Alright, so I've put together some code. I've defined my complex class by basically defining a complex point. So instead of using x and y, I'm going to use the point structure I just made. So I have a constructor for the complex for an empty constructor with a real and imaginary number, so 2 doubles. And then I also made it so we can just construct it using a point. I suppose a third constructor, I could also have the copy constructor from complex. There we go. So we'll call this complex C, and then we'll just define the complex point to be, we'll create a new point using c.getReal and c.getImaginary. Alright, so this line is maybe a little bit complicated, but we're creating a point, and we're using that point to create a complex, we're just assigning it to the complex point. And so we're creating a point here using the real and imaginary values from the complex value that's been passed in. I guess I forgot to set that one up. Yeah, let's try this program out. We'll come back to the main. I've added just a couple complex numbers here. We have a complex number D, E, and F, where D is being created. Actually, you know what? Let's double check. Let's make sure we've looked at everything here. So the empty constructor for the complex, we just create a point. We set the x and y. Then the complex, if we have 2 reals, we're creating a point using the real and imaginary. Very, very similar structure to what I did here in the complex.h. And I did this to show that we can use this list initializer in the header file or in the CPP file. We can do it both places. Alright, so when we get the real, we're going to return the x value from the point. When we get the imaginary number, we're going to return the y value from the point. When we're setting the real value, we're going to set the x value of the point. And when we're setting the imaginary number, we're going to set the y value of the point. Set real, set images. Yeah, they're the same. Anyways. Alright, when we print to screen, I have a quick check here. I want to make sure that the imaginary part is greater than or equal to 0. And in that case, we're going to use I. Otherwise, we're going to use a minus sign. And if we're using the minus sign, the get imaginary is less than 0, so we want to turn it into a positive, so I'm going to just do the negative there. Alright, let's print these out. We're going to do d.print to screen, e.print to screen, and f.print to screen. Alright, and when these print, you can see that everything prints sort of the way we want. 0, 0, pretty much what it should be. Yeah, everything's perfect. We can also try things like, you know, complex G equals sum E F, G.print to screen. See if our sum is working. Oh, I called the complex one add, so I'm going to change this to sum. Complex, here's sum. This is kind of an important point. So here, because the input types are complex, it's going to know to use the sum from the complex and not the sum from the point. We call this overloading, and it's important to know. So we're actually able to take the E and F and add them together. So you can see if we take the 1 plus 3, we get 4, minus 4 minus 10, we get minus 14, and everything is working.